What is it, Hidato? Hidato Hex, this is a puzzle shaped like a hive which should be full with numbers. The rules are as follows. The sequential numbers should be close together. The intention is that 1 must be close to 2, 2 must be close to 3 and to 1, 3 must be close to 4 and to 2, and so on. This is example from an Israeli newspaper. What are the main goals of the project? Find a path that meets the rules of the puzzle in the most effective complexity. Generate new puzzles that meet the rules of the puzzle. Find the path that meets the rules of the puzzle in the most effective complexity. To find the appropriate path in the most effective complexity, we will have to find efficient search algorithm. We will use DFS, depth search, to find the correct path using backtracking recursively. Backtracking, how it works. Let's see a short video that demonstrates how it works. Key number and intermediate path. The Hidato puzzle is designed so that there are numbers riding inside a hive, which help to the user to solve the puzzle. These numbers called key numbers. The shorter paths between the key numbers called intermediate paths. It is important to understand this definition in order to understand the report. Let's look at some examples. In this Hidato, we have 6 key numbers. 1, 3, 6, 11, 16, 19, and 5 intermediate paths from 1 to 3, 3 to 6, 6 to 11, 11 to 16, and 16 to 19. So how many paths the algorithm calculate? It's depending on the quantity of key numbers and depending on the length of the intermediate paths. Let's define the hive to be numbered with the indexes. Let's look at this example. The paths from index 4 to index 2 are: the first path will be 4, 1, 5, and 2. The second path will be 4, 5, 1, and 2. The third path will be 4, 5, 6, and 2. And the last one will be 4, 9, 5, and 2. In total, we have 4 paths between index 4 to index 2. Generate new puzzles that meet the rules of the puzzle. Hamiltonian path is a path which allowing to visit each vertex exactly once. In other words, the path will not visit same vertex more than once. It will visit through all vertices of the graph and will build a unique resolvable path. Hamiltonian path. Let's try to build a new randomized path without the principle of Hamiltonian path. Let's define the hive to be numbered with indexes. Let's look at this example. Assume that the path starts from index 2. So, the path will be 2, 3, 4, 1, 0, and that's it. The path that created reached dead end. In other words, the path cannot move any further, while the indexes 5 and 6 were not visited yet. This situation is contrary to the rules of the format. The Hidato created illegally. How Hamiltonian path will eliminate this problem? Let's back to the path a few steps before. In this case, Hamiltonian path will visit the index 0 or index 5 after index 3. This will ensure that all vertices appears in each generated path. So, what we did and what we have left to do. The first goal towards the end. We are currently working on optimizing algorithm to the maximum level, as the main idea works. The second goal is launched. We will begin work on the Hamiltonian path and generate automatic puzzles. And of course, a GUI program, and user interface.